Like I said earlier, this is just an extension of yesterday's notes. It's part 2. So we're just talking about more of our transformations today. Another way to transform the graph of a function is to multiply all of the y coordinates by the same positive factor other than 1. When the factor is greater than 1, the transformation is a vertical stretch. When the factor is greater than 0 and less than 1, so between 0 and 1, it is a vertical shrink. So today we're going to be stretching the graph or shrinking the graph vertically. Okay? Any questions about that? It's just another type of transformation for us for our graphs. And once again, it's when we multiply all of the y coordinates by the same positive factor other than 1. Can I move on to an example? It says graph each function and its parent function, then describe the transformation that occurs. So letter A, I've got g of x equals 2 times the absolute value of x. And then letter B, I've got h of x equals 1/2 x squared. So let's start with letter A.
How do you get the square root of the unknown?
Oh, remember we picked x values to plug in to get our y values, right? So we're going to pick x values to plug into our table of values to get our y values. So we'll get a bunch of ordered pairs that we can graph. And we'll graph them.
No.
And which function family is letter A a part of? If it's y or g of x equals 2 times the absolute value of x. Absolute value parent functions. Okay? So, let's create a table of values for letter A. Picking x values to plug in, and it'll give us our g of x values or our y values. So I'm going to use kind of the same numbers I used yesterday. -2, -1, 0, 1, and 2. I just picked my x values randomly. Okay? Plugging -2 in, I'm going to take the absolute value of -2 and then multiply that number times 2. So what's the absolute value of -2?
2.
2. And then 2 times 2 gives me
4.
4. We okay with that?
Oh my.
We okay with that? Okay, plug -1 in. What's the absolute value of -1?
1.
1. What's 2 times 1?
2.
2. We okay with that? Everyone see what I'm doing? Picking x values, plugging them into my function to get my y values. Plugging in 0. What's the absolute value of 0? 0. What's 2 times 0?
I have a question.
0. Yes.
What is the point? Oh, never mind, because it's the x. It's
Say it
like
again.
the x. And never mind. I'm good. I got
We're
it.
good?
Yeah.
Okay, absolute value of 1. 1. 2 times 1? 2. Absolute value of 2? 2 times 2.
2.
So these are my ordered pairs. -2, 4. -1, 2. 0, 0. 1, 2, and 2, 4. What is my parent function of the absolute values?
Absolute value of x.
Very good. Absolute value of x. So if I plug these same values in, because remember it wants me to graph this function and the parent function with it. What's the absolute value of -2?
2.
Absolute value -1.
1.
Absolute value 0.
0.
1.
1.
2. We okay with that? So it'd be -2, 2. -1, 1. 0, 0. 1, 1. 2, 2. Is everyone okay creating a table of values? Yes, no, maybe so. Okay. So now we need to graph all these ordered pairs on the same graph, correct? So here is our letter A continued. I went ahead and put the graph of it up here because it looks a lot nicer than if I were to draw it. I want y'all to see this visually. So, this blue graph is my g of x function, 2 times the absolute value of x. This black graph is my parent function, f of x equals the absolute value of x. Does everyone see that? So, I graphed it, and it wants me to describe my transformation. Does it look like I stretched my graph, my parent function? Or does it look like I shrunk it? Looks like I stretched it. Looks like I took it right here and I pulled it farther away from the x-axis. Does that make sense? So, the y-coordinate of each point on G is 2 times the y-coordinate of the corresponding point on the parent function. So the graph of G of x equals 2 times the absolute value of x is a vertical stretch of the graph of the parent absolute value function. Does everyone see that? And over here, says when the factor is greater than 1, the transformation is a vertical stretch. What was our factor here?
Greater than 1.
What was our factor?
2.
2, which is greater than 1, so I knew it was going to be a vertical stretch before I even graphed it. Right? Does that make sense? Any questions on letter A? Okay, let's do letter B real quick.
It's like, hey. No.
We're good? Letter B. Let's go ahead and identify our parent function for letter B. What's the parent function for letter B? If I have, it's x squared. Very good. F of x equals x squared. What do we call this family of graphs?
Horizontal.
Nope. Quadratic. Very good. This is our quadratic function family because it's got a squared term in there. X squared. So let's create a table of values for our h of x function. -2, -1, 0, 1, 2. Okay, plugging these values into x for h of x. So I'm going to square my x values and then multiply them by 1/2. Does that make sense? So what's -2 squared? 4. What's 1/2 times 4? 2. My first ordered pair is -2, comma, 2. We okay with that? Okay, -1 squared. 1. 1 times 1/2? 1/2. 0 squared. 0. 0 times 1/2? 0. Okay, 1 squared. 1. 1/2 times 1? 1/2. And then 2 squared?
4.
4. 4 times 1/2?
2.
2. So here's my ordered pairs for h of x equals 1/2 x squared. -2, 2. -1, 1/2. 0, 0. 1, 1/2. 2, 2. Do you guys remember what we call the graph of this? The U shape. What do we call that? Parabola. So when I graph my points, I know I'm going to be connecting them with that U shape, that parabola. Right? Don't try to make it a V like the absolute value. Try to make it the U shape like the quadratics.
That's when you're dealing with
Okay.
halves.
Say it again.
Is that just when you're dealing with halves?
No, it's when I'm dealing with x squared terms, quadratics.
Uh,
Okay? If I'm dealing with absolute values, I know my graph's going to be a V shape. If I'm dealing with quadratics, I know it's going to be that U shape, the parabola.
the curve.
Okay? If it's linear, I know it's going to be a straight line. And then if it's a constant, I know it's going to be a horizontal line. Okay? And let's go ahead and fill out our table for our parent function. -2, -1, 0, 1, and 2. What's -2 squared?
4.
-1 squared,
1.
0 squared,
0.
1 squared,
1.
2 squared.
4.
We okay creating a table of values?
Yeah.
-2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Do you think this is going to be a vertical stretch or a vertical shrink?
Definitely.
Why?
I'm just guessing.
Okay, well you got it right. Yes.
Because it's between 0 and 1.
Very good. My factor is 1/2, correct? Multiplying all my outputs by 1/2.
I was gonna bring them down.
So, when the factor is greater than 0 and less than 1, aka between 0 and 1, I know it's going to be a vertical shrink. So it's going to be like I'm shrinking it towards the x-axis. So it's going to be getting wider as opposed to more narrow. Okay? I know that based on my factor. Okay? Here's our graph right here. The blue graph is my h of x function. The black graph is my parent function. As you can see, it kind of shrunk a little bit. It got wider because I'm shrinking it down towards the x-axis. Does everyone see that? The y-coordinate of each point on h is 1/2 of the y-coordinate of the corresponding point on the parent function. So the graph of h of x equals 1/2 x squared is a vertical shrink of the graph of the parent quadratic function. Are there any questions about our example 4 here? We okay? Example 5. Describing combinations of transformations. It says, use a graphing calculator to graph g of x equals negative absolute value of x plus 5 minus 3 and its parent function. What would the parent function be here?
X plus. Can't tell what number that is.
If it's an absolute value function, what's the parent function of that?
Absolute of x.
Very good. f of x equals the absolute value of x. So,
Means it's gonna be.
I don't have all my batteries yet for my graphing calculators. I'm still in the process of doing that. So I put the picture of the graphing calculator up here. So you type this in your graphing calculator. G of x equals negative absolute value of x plus 5 minus 3. Hit enter. It should graph it. Then I can go to the table and create another equation. F of x equals the absolute value of x. Hit enter, and it should graph them on the same graph like this. Here's my parent function. Here is my g of x function. So I knew it was going to be a V shape, correct? What transformations happened from my parent function to my g of x function? Someone raise your hand and name one transformation that occurred.
Reflection.
Reflection over
The y-axis. X-axis.
the x-axis. Very good.
I see it.
It is a reflection over my x-axis. Someone raise your hand and tell me another transformation that occurred.
I see a translation.
A translation. What kind of translation?
An X translation.
Horizontal or vertical?
Horizontal.
Horizontal. How many units did it get translated to the left?
3? I don't know. 2.5. 4.5.
That's 3 and
3.
a half.
3. And 2 down.
And how many down?
Looks like 1 or 2.
Hard to tell.
1.5.
So these go by twos. So it's actually not 3.
4.
2, 4,
All in
2, 4, 5.
Oh.
My eyes
It'd
hurt.
be 5 to the left, correct? And then how many units down?
3.
Huh?
3.
It is 3.
I can't see it.
2, 3. Okay.
How do you see it?
We also know these numbers based off of our function. Okay? 5 units to the left, 3 units down. If it's inside grouping symbols, you do the opposite of what the sign is telling you to do. So if it's inside, it's going to be a horizontal translation. So this plus 5 tells me it's going to go to the left 5, because I do the opposite of what the sign says. If it's outside of the grouping symbols, it's going to be a vertical translation, and I do what the sign says. So it's a minus 3, so I'm going down 3. Does everyone see that?
And
The
left
negatives, say it again.
5. And left 5.
Yep. If I'm inside, it tells me to do the opposite. So you would usually think I'd go right 5,
Got it.
but it's plus 5, so I go left 5. Outside tells me to do what you think you would do. Minus 3 tells me to go down 3.
What's up plus 3 go up to?
And if it said minus 5, I'd go right 5. The negative outside, that tells me it's going to be the reflection over the x-axis. Okay? So the graph shows that g of x equals the negative absolute value of x plus 5 minus 3 is a reflection over the x-axis, followed by a translation 5 units left and 3 units down of the graph of the parent absolute value function. We okay with that? Did it stretch or shrink it at all?
Whoever made this up.
Did it stretch or shrink it at all? No. There's no factor being multiplied by my function, is there? It's just the reflection, the horizontal translation, the vertical translation. Okay? Questions on example 5? Here we go. I'm done.
Oh, dang.
Page 15, numbers 19 through 26 off.
Thanks, guys. All right.
You're welcome.
This dude got Air Georgia on. Time, right? Let me see that.
This will be due Thursday, December 9th on Canvas. Are there any questions about my notes before I end the recording?